Hello, my name is Kenny. I'm from Harmony School of Science, and this is my Math Level 3 PBL project on the Ruby sequence. The purpose of my experiment was actually to analyze trends in a series of numbers that's actually derived from the Fibonacci sequence and determine whether they have distinct patterns that are relevant in nature. Before I begin describing my project, I would like you to understand what the Fibonacci sequence is to see the sequence I derived from that. The Fibonacci sequence is actually a series of numbers that actually expounds on itself in order to code for growth in nature, whether that be the growth of trees and the formation of branches, whether that be the formation of the female uterus or the formation of galaxies or sunflowers. It simply allows a proper and systemic growth of things. Now the ratio found in the Fibonacci sequence is very relevant. It's been relevant in certain forms of art, like the creation of Greek temples, and in making these temples they actually took the ratio found in the sequence, which is 1.618. That is called phi, which is the golden ratio, and they used the proportions from that ratio in order to build certain things. Now the series of numbers that I did research on was called the Jacobstal numbers, and these numbers, like the Fibonacci sequence, do something quite similar. The only difference is rather than any number in the sequence being the sum of the two preceding numbers, it is actually twice the preceding numbers to get the next number. That is how the Jacobstal numbers work, and the relevance of it isn't well known. Not many people have done research on it, which is why I call it the Ruby sequence, because the discoveries in it are actually quite rare, but quite phenomenal nonetheless. One of the things I'd like to talk about concerning the Ruby sequence is how the ratios found in it can actually determine how beautiful a person is depending on the proportions on their face. A great example of that would be, I actually got a list of 10 different famous celebrities, and many of these celebrities are known for their good looks. I got a couple who are not, and we could actually compare the numbers that they got based on my sequence in order to determine whether math actually proves why they're beautiful or not. So I got certain people like Adam Levine and Trey Songz. They had good ratings according to my ratio and that of the Fibonacci sequence. You see them getting stuff like 1.618 or 2. Those two ratios are found in the Fibonacci sequence and in the Ruby sequence. And then you see people like Nicolas Cage. No offense to him, he didn't have quite good ratings. That being said, someone like let's see, Beyonce had really good ratings. Alicia Keys had actually one of the best. One thing to notice on this ratio chart is I took certain measurements like the top of the head to the chin or the top of the head to the pupil and actually took the quotient of that to get these ratios. The actual ratio that had the most Ruby ratios, which is 2, was actually from the width of the nose to the tip of the nose to the lip. And that almost all of them were about 2 for people who are considered considerably handsome or beautiful. Again, as I said before, the limiting ratio in my sequence is actually the value 2. And what happens is when you start the sequence, the ratio begins as 1. It then goes to 3, but then it continues fluctuating around 2 until it finally reaches that limit. Also, when it comes to the growth of certain animals in nature, as in their length to height or length to width proportions, that also tends to follow the Ruby sequence as well. When you have grizzly bears, they start off as little cubs, but then as they grow, their proportions begin to match that of the Ruby ratio, in that their length usually levels off at about 6.5 feet, and their height from their paws to their shoulder is usually around 3.25 feet. And that's a 2-to-1 ratio right there, which is proved by the sequence I presented to you today. The last thing to really consider is actually music. It's not only in nature that you see these certain trends, but also in the musical patterns that are utilized in making measurements of frequencies and certain pitches of notes. An octave, for example, is actually the musical unit of measurement between any pitch and a note of twice that frequency. It's something that's often used in making certain songs, in that you might have the note A, and then you might have another A, but the other A would be twice the frequency of the previous A. And it's important to note this simply because the relationship between any two notes that are the same but of different frequencies is actually a 2-to-1 ratio. In order to conclude, I would actually like to talk about the woman's uterus. This actually shows the direct relationship between the Ruby sequence and the Fibonacci sequence. The woman's uterus, when at birth, a female will have a uterus of about 2-to-1, the length to width proportions. But then as they get older and they're in their most fertile years, which is usually around 21, it actually levels off to a 2-to-1 ratio. It levels off to a 1 to 1.618 ratio, which is that of the Fibonacci sequence, showing the direct relationship between the two. Finally, I would just like to talk about my ELA component for this research. That would actually be the journal entries I did every day. As I researched, I would document the certain data that I collected regarding these patterns that I discovered, as well as the ratios of the face and other things in nature that presented evidence for the Ruby ratio. Also, there are certain historical connections when it comes to the sequence of numbers, and that Leonardo Pisano, during the Renaissance period, actually created the Fibonacci sequence in the first place, which allowed me about 400 years later to actually create my own sequence based on that. Also, a certain scientist by the name of Lucas did something quite similar, and so did another mathematician, a German mathematician by the name of Ernst Jakobskel, who actually created the sequence of numbers in the first place, but was yet to actually discover the patterns found in it as I have. That is all. Thank you for watching Harmony Public Schools.